Today's legacy data platforms slow innovation and delay decisions. Modernizing these platforms is essential to unlock real-time insights, enhance agility, and drive business growth. It's not just a tech upgrade, it's a transformation that powers smarter, faster, and more collaborative data-driven organizations. Traditional data and analytics platforms have long been the backbone of business intelligence, but as data volumes exploded and business needs grew more complex, these legacy systems quickly became obstacles instead of enablers. Here are some of the challenges that I personally noticed. One major challenge was the complexity of infrastructure management. Manual setup of networks, patching, scaling, backups, and disaster recovery created heavy operational overhead and increased downtime risks. Performance was another bottleneck. During peak workloads, platforms would slow down considerably, frustrating users and delaying critical insights. Storage limitations and rising costs forced compromises, limiting data retention and scalability, which in turn constrained historical analysis and decision-making. Security and governance were manually intensive, increasing risk and administrative burden without much automation or centralized control. Plus, these platforms lacked native real-time processing and AI/ML capabilities, preventing timely insights and modern analytics automation. Finally, fragmented data silos and complex integrations slowed development and made collaboration difficult, delaying time to market. All these pain points illustrate why organizations, including myself, have been motivated to modernize, to reduce complexity, boost agility, lower costs, and unlock real-time intelligence that drives competitive advantage. The centralized versus decentralized dilemma is yet another challenge that organizations face. The diagram on the left depicts centralized enterprise BI, which is IT-owned BI with a center of excellence team that builds and publishes enterprise-grade models, reports, and more to various departments through Power BI Fabric workspaces. They're typically published in Power BI apps and are read-only to the rest of the organization. Downstream business consumers and analytics teams can consume the published read-only artifacts as a managed self-service. This approach provides great governance and standardization from the central BI Center of Excellence, but comes at the cost of speed and potentially depth of insight and detailed domain-oriented analytics. The diagram on the right, on the other hand, represents departmental BI. When BI is decentralized as part of a business analytics division, each of these new teams would be responsible for their focus areas. While this seems like a great way to provide deep domain expertise to the business and speed of delivery, the pitfall is that the BI Center of Excellence has completely been dissolved with this approach, and each siloed team is left to apply its own standards, governance, integrity, and administration. Now this can result in some issues, especially if no distinction has been made regarding the analyst versus developer roles. This diagram illustrates a large-scale Azure MLOps platform supporting hundreds of data science teams and thousands of models in production. Core components like Azure ML and Model Registry can be complemented or replaced by Databricks and MLflow, for example. Typically, a data scientist requests an experimentation environment via a ticketing system. After passing governance approval, a DevOps pipeline provisions the necessary compute, storage, and access to enable agile experimentation without manual delays. Once a model is ready, it's committed to Git, triggering a CI/CD process. Machine learning engineers harden, retrain, and publish the model to a centralized registry, deploying endpoints for downstream use. Automated monitoring detects model drift and retrains as needed, while ensuring security and auditability. However, it's important to note that this decentralized PaaS-based MLOps setup is not a unified SaaS analytics platform. Governance is fragmented, with varied tools and standards across teams, leading to duplicated control, increased risk, and inconsistent policies. Operational overhead is high due to manual environment setups and inconsistent pipelines, slowing development and increasing errors. Collaboration suffers from scattered toolchains and registries, causing silos and limited knowledge sharing. As the number of teams and models grow, the lack of standardization becomes a major bottleneck. In contrast, unified SaaS platforms like Microsoft Fabric or Databricks delivers centralized governance, security, and compliance uniformly across domains. They automate provisioning and enforce standardized CI/CD, speeding delivery and reducing errors. Integrated monitoring and lifecycle management ensures models remain accurate and available. Seamless self-service and collaboration empowers business users and data scientists to innovate within clear controls. And most importantly, Fabric scales effortlessly to support thousands of users and models without operational chaos. While decentralized PaaS MLOps addresses local automation needs, integrated SaaS platforms like Fabric and Databricks offer the combination of ease of use, agility, and enterprise discipline necessary for modern AI and analytics at scale. Before we dive into the benefits of modern unified platforms, it's helpful to take a quick look back at how Microsoft's data platforms evolved over the years. It all started more than 30 years ago with SQL Server's launch in 1989. Over time, it expanded through the business intelligence and big data phases, eventually leading us to today's cloud-first approach. Starting with on-premises infrastructure, organizations had full control over their data and systems, but this came with high costs, complexity of maintenance, and limited scalability. Then came infrastructure as a service, or IaaS, which moved hardware management to the cloud. This eliminated the overhead of physical servers and allowed flexible scaling. The catch? Users still needed to manage the operating system, middleware, and applications themselves. Next, Platform as a Service, or PaaS, abstracted away platform management entirely. Developers could focus on building and deploying applications quickly without worrying about managing the underlying infrastructure. However, organizations still had to build and maintain their own apps. Finally, Software as a Service, or SaaS, offers fully managed applications accessible over the internet. This reduces IT effort, provides centralized governance, and ensures easy scalability, although it offers less customization and control over the platform. Today, unified analytics platforms combine aspects of both PaaS and SaaS to deliver powerful, scalable, and governable solutions all in one place. So it's quite clear that a unified data and analytics platform transforms how organizations manage and leverage data by consolidating storage, processing, security, and analytics into a single scalable environment. Let's look at some of the benefits of these unified data and analytics platforms. Scalable data storage and processing. So modern unified data platforms automatically scale to handle massive, rapidly growing data sets without bottlenecks. SaaS solutions offer flexible pay-as-you-go or reserved resource models, reducing costly hardware investments while delivering virtually unlimited cloud storage and decoupled compute capacity. This elasticity ensures that businesses can grow data volumes seamlessly without disruption. Number 2, rapid access and streamlined collaboration. By enabling real-time data sharing and integration across departments, vendors, and institutions, these platforms break down silos and foster collaboration. Access to standardized, well-documented data accelerates joint analysis and discovery, while easier interagency and public data sharing drives innovation across systems. Cost optimization and resource efficiency. Centralizing data management in the cloud significantly lowers upfront capital expenditures and reduces ongoing operational overhead. Built-in unified governance, security, and compliance handled by the platform provider minimizes manual effort and risk. SaaS and PaaS offerings also support consumption-based pricing, letting organizations pay for only what they use, maximizing ROI and minimizing waste. Enhanced security, compliance, and data governance. Modern unified platforms deliver robust automated security controls, traceability, and compliance features essential for federal and industry regulations. Improved auditability and data quality frameworks help ensure data integrity and resource adherence with less manual workload, protecting organizations against risks and penalties. Number 5. Accelerated research and innovation. Unified PaaS and SaaS platforms provide pre-configured tools and workflow automations for analytics, machine learning, and AI, dramatically shortening the experiment and development life cycles. Advanced analytics include deep learning and Gen AI, which can rapidly be deployed and scaled to new use cases, empowering agile innovation and faster realization of business value. Overall, unified platforms simplify complexity, boost agility, optimize cost, and unlock advanced analytics capabilities, enabling organizations to make faster, smarter, and more collaborative data-driven decisions in a scalable, secure environment.